Alright, for my intervals, I'm going to choose the following: 4 to 5.5, 5.5 to 7, 7 through 8.5, 8.5 through 10, 10 through 11.5, and finally 11.5 through 13. I have 6 intervals. Frequencies for each of those: 3, 4, 8, 6, 1 and 1, 1 and 3. In this case, make sure that you understand exactly that you'd get that those same numbers. Alright. For instance, it's very important that you understand that the second interval, 5.5 through less than 7, does not include the 7s. So we have 2 7s in this data set. They would be in the third interval, 7 through less than 8.5. Alright, etc. Alright, so this is our frequency distribution. That's the first step. Next step is to do these calculations, first for the average variance standard deviation, and for that we'll need columns x, fx, and fx squared. Alright, the x's are just the midpoints. So for this data set, it'll be, for these intervals, will be 4 3/4, 6 1/4, 7 3/4, 9 1/4, 10 3/4, and 12 1/4. Alright, at this point we could do our calculations. Fx, 3 times 4 3/4. Alright, these numbers not so cute, so I'll just write them down. It's 14.25, 25 0 0, 62, 55.5, 10.75, and 36.75. fx squared, alright, again not so cute at all. X squared, that's 4.75 squared times 3, 67 point, and I'm going to round these off, 69, 156.25, 480.50, 513.38, 115.56, and finally 450.19. Even though I've written these fx squareds in rounded format, I have the good numbers in front of me. We're going to add these columns. Again, never the x's. Don't ever do that to break that habit, because it'll lead you into trouble. Alright, add the frequencies. It's 25, so sigma f is 25. fx, 204.25. And fx squared, 1783.56 approximately. Alright, and then we can calculate the average variance and standard deviation. So let's reproduce those numbers here. Sigma f is also the n, which is 25. Sigma fx is 204.25, and sigma fx squared is 1783.56. So the average x bar sigma fx divided by sigma f is 204.25 divided by 25. It's exactly 8.17. Okay, and you'll notice, going back to your table, that most of the data points are close to that. Most the modal interval is 7 through less than 8.5. So that makes sense that the average is there too. The variance, S squared is sigma fx squared minus n times x bar squared divided by n minus 1. Fx squared is your 1783.56 minus n 25 times 8.17 squared divided by 25 minus 1. And the S squared boils down to 4.785. So that's our variance. And our standard deviation, S, is equal to the square root of that. Okay, and then there's one last thing we need to do, and that's to find the median. And what I'm going to do is to write up the table and pause the recording for a while. And of course, each time I find myself calling this tables, but these are the frequency distributions. Alright, what we need to next to calculate the median is the cumulative frequency. Alright, so the number of items less than 5.5 is 3. The number of items less than 7 is 3 and 4 is 7. The number of items in the data set less than 8.5 is 7 and 8. 15. Number of items less than 10 is 15 and 6, 21. Number of items less than 11.5, 21 plus 1 is 22. And finally, 22 plus 3 is 25. Alright. Make sure always that the sigma f and the cumulative frequency at the end are the same, because they have to be. So then we look for the median item. Is the n on 2 item, or in this case 25 divided by 2. Don't round this off, it's the 12.5 item. So we're going to go through the data set and look for the 12.5 item. Alright, so it's not in the first interval because we have items through items 3. The second interval has items through items number 7, and then the third interval has items through item number 15. So we've just bypassed 12.5. Alright, so the 12.5 item is here. So this is the median. So that interval 7 through less than 8.5 is the median class. Alright, so then we have to go ahead and identify these things. L, the lower limit of that, is 7. I, the width of the median class, they're all the same, 1.5. N, we already have, is 25. Capital F, the frequency up to the median class, there are 7 items below the median class. And then little f, the number of items in the median class, and that's 8. Alright, so we're ready for our formula. L plus I n divided by 2 minus capital F divided by little f. So it's 7 plus 1.5 times, and we'll do the n on 2 in our head, 12.5 minus 7 divided by 8. Alright, and that boils down to 8.031 to 4 significant places, even though it's far too accurate given the amount of rounding off we're doing here. Make sure that once you have your calculation for the median item, or the median, in this case 8.031, make sure it's actually in the median class that you identified. So 8.031 is between 7 and 8.5. Alright, so we're good. Alright, so that's the calculation of the median.